Okay, so you should be at page 40 in your book, section 1.6. And this is just kind of an introduction to integers. And integers are kind of nice positive and negative numbers, including 0. So read this direction and then fill in this chart here. So just read what it says up here. We're going to do a tiny bit of chemistry and then fill out this chart, and then we'll go from there. All right, so as you read, every single proton has a positive charge. So each one has a positive charge. So like we could write positive 11. And even if you don't write the positive, it's assumed that it's positive if it doesn't have a symbol. So every single one of these carries a positive charge. And then for electrons, every one of those carries a negative charge. So there we have to put the negative so people know it's negative. Okay, so every single proton, every one of them has a positive charge, and every single electron has a negative charge. Okay, go ahead and pause and answer question number 2, and we'll catch up there. Okay, so for question number 2, your net charge is going to be the sum of the charge from all your protons and electrons. So if we look at up here, this sodium atom right here, it had a positive 11 charge that we put over there and a negative 11 charge that we put over there. So its net charge is 0, okay? Where like the ion right here, this ion right here had a positive 11 here from that number and a negative 10 over here. So a positive 11 and a negative 10, think of money and debt, like pay off your debts and how much money do you have. So there'd be a positive 1 net charge for that. So what I want you to do is go down to question number 3. And then go ahead and read the directions there and try filling out the chart for number 3. Okay, so on this one, what they want is how many you have. Here it's the number of electrons, so you're not going to put a negative number in here. This is how many there are, not necessarily their charge. So the number of protons, the number of electrons, and then the net charge, because we know that all of these would have a positive charge and so forth. Couple things you need to remember is that an atom has a neutral charge. So if you look here, an atom has a net charge of 0. So that means there weren't positives left or negatives left. So are you okay that there would have to be one of those? Because if there's one positive, there would have to be one thing that's negative, so that it ends up at 0. The other thing you need to remember is that an ion is just like an atom, but electrons can come and go. So protons are what I always like to say permanent. They can gain or lose electrons, but not protons. So protons are permanent. So since these are both hydrogen, if this has 1 proton, this had to have 1 proton too, because protons are permanent. Electrons can come and go. So since the net charge was a positive 1, that would mean this would have to be 0. So if you were kind of stuck, try finishing the rest of the chart, and then we'll go from there. So again, atoms are neutral as far as charge. Ions might have positives, or ions might have negatives, but protons are always the same between an atom and an ion. It's just the electrons come and go. So see if that helps you finish out the chart. All right, so let's finish this out. So again, atoms are neutral, so we know this is going to be 0. So if there's 8 negative things, there must have to be 8 positive things. So that this would be a positive 8 charge, negative 8 charge, 0. Okay, again, oxygen on oxygen, these guys have to match. Protons are permanent. They don't go anywhere. So that means the electrons had to come or go. Well, to get a negative 2 charge, I would need more negative stuff. So that means I need 10 negative things to compensate for the 8 positive and still have 2 negative left over. Here, again, calcium with calcium. Protons are permanent. And so then I know atoms, I'm like, okay, they have to be neutral. So if I have 20 things that are positive, I need 20 things that are negative. And here I have a 20 positive. And then if you look right here, that little thing tells you the net charge. So, excuse me, I know that's positive 2. And again, these guys come and go. So if I had 20, it would be 0, which is what this is. but I need more positive. So some of these are going to go away. Some of the negative things are going to go away. So I have positive left. So if you look in this corner, that 1 means a net charge of 1. That 2 means a net charge of 2 because it has a negative after it. And then 2 positive means net charge of 2 positive. All right, go ahead and try number 4 and then read the green box on page 41. All right, so number 4, describe the kind of number that you'd have. So for cars in a parking lot, you know, hopefully we can't have half a car or anything like that. So if we're thinking about that, we're probably thinking of maybe whole numbers. And whole numbers don't have decimals or fractions, but start 0, 1, 2, 3, 4, things like that. Depth of a submarine relative to sea, and it's descending at a rate of this many per hour. So probably, you know, obviously we're below sea level, so negatives would make sense. And it could be really any type of negative number, like decimals, fractions, like negative half a mile, you know. So fractions, decimals would probably be fine, but definitely negative because we're below sea level. Let's see, you're going to share a candy bar here. Probably would have to be positive, right? Because obviously you're not going to owe it. But it probably could be a fraction, like I might share half the candy bar. Or it could maybe even be a decimal. You know, I'm going to share 0.25 or 0.5. So if fractions work, decimals are going to be okay too. And then spreadsheet to keep track of money. Don't do fractions very often with money. Sometimes financial stuff has fractional values, like sometimes like borrowing money for a house, like interest rate might be 3 5/8%. But for the most part, money is definitely decimals. And again, really could be positive or negative. So you could have either type of decimal. All right, let's look at the vocab here and we'll go through this quick. I'm going to pause for a second and yeah, then we'll talk about the vocab. My dog needs out of the door here, so. Okay, so again, bold, green areas, make sure you read these. Negative numbers have 2 parts to them, kind of whether the sign, which tells they're negative, I guess any number has 2 parts to it. If it's positive, we just don't write it. But if it's negative, we have the sign and then the size of it, so how big it is. Absolute value is when we put the little bars around it, like down here. And what that really means is a distance, like how far is it from 0. So if you look down here at the number line, positive 5, if I put the little bars around it, it has an absolute value of 5 because it's a distance of 5 from 0. But notice negative 5, if I put the bars around it, I'm asking how far is it from 0. And we don't really say it's a negative 5 because distances, that doesn't make sense. So it's still a distance of 5. So the absolute value of 5 is 5 because it's a distance from 5. But the absolute value of a negative 5 is also 5 because it's 5 away. Opposites are things like 2, -2, 3, -3, 4, -3. Those are opposites. And integers are your nice positive and negative numbers and then 0. And so we have some negative numbers here, positive, and then 0 is neutral because it's neither positive nor negative. So, but all of those make up the integers. All right, let's turn the page. All right, go ahead and answer actually all this page. Okay, so pause the computer and I'm going to pause and answer, at least get through 7. Let's see. Yeah, go ahead and answer all of them. All right, and then we'll talk about this page next. All right, so let's look at these. So the first question is, what is the opposite of a -8? So kind of like, what is the opposite of owing $8? Well, that would be a positive 8, having $8. In math, the way we'd, grabbed the wrong thing. The way we'd write this is the opposite of a -8. And so when you take the opposite of a negative, that's going to end up making it positive. This is saying what is the absolute value of a -11, which is really saying how far is it from 0, which is 11. Here, what is a sign of 24 and the size of 24? So if we don't put anything, the default is positive, so it definitely has a positive sign. And the size of it would be, it has a size of 24. Here, the parenthesis doesn't mean anything. It just means like it's trying to draw attention to that negative number. So it's really like the same as up here. So what is the opposite of a -6? So the answer would be a positive 6. So again, those two negatives are going to undo each other because the opposite of a negative is a positive. This is different. These negatives will not undo each other because you're going to have to get the distance first. So this is saying the opposite of that distance. So the distance is 6, and this is saying the opposite of that distance. So that's going to end up being a -6 because the answer to this is 6, and then that negative is just going to kind of come down there. All right, so the next one, let's see, 100 feet below sea level is -100. And 500, if you're in the red, it means you have debt. If you have money, you're in the black. So positive 500, and again, you don't have to put the positive sign. You can just put 500. That's why we call it Black Friday, by the way, because that's when stores actually show a profit. And I just lost my screenshot. Where did it go? There we go. All right, so the next one, if you lived in California, this one might bother you. You might be like, I have no idea, but we live in Iowa. So that means that it's 30 degrees below Fahrenheit. So if you think of a thermometer here is negative, we are 30 degrees below. A pool has a plus or minus margin of error. So what that means is you're going to take it and you're either going to add 3% or you're going to subtract 3%. So it's kind of like how far off it could be. So if someone has a 48% and, you know, if I add 3% to that, they really could be at 51%. And if I subtracted 3%, they could really be at 45%. So it just kind of varies. All right, and then this last one, I kind of ran out of space. Let's see if I can get out of maybe this guy and maybe scroll down. There we go. All right, so if you look at this graph, oh, sorry about that. Look at this graph, all right? So it says, write a sentence to explain Lily Lake's enrollment. So Lily Lake is right here, all right? And so basically between the years of what, 2013 and 2018, they saw a drop of about what, 12%, because here's -5%, -10. So their enrollment dropped about 12%. All right, let's see. So the next page, let's go over there. Yeah, if you're in chemistry, you might want to read that, but we're not going to worry about it. And just know at the end of every section, it kind of tells you what you were supposed to learn. So if you're like, did I get everything out of this section that I was supposed to? Maybe read that. All right. And then again, here's kind of just a nice little reminder of, yes, it's going to be hard work, but there's going to be harder sections. There are going to be easier sections. So it all kind of balances out. And then you're going to have time to actually learn the material. So every single day in class, we will review and practice and, you know, work on videos to help you guys out. But these are things that, you know, are just really good reminders. So if you look at the next page. All right, so this is a homework page. So on this page, do 1 through 7. So 1 through 7 on this page, and we will stop there.